Kia ora, this is just the second part of the long 15-minute video with the perms and comms question, so probably not much point watching unless you've followed right through till the end of the last one. I am going to do the third part of the question in this video though. Okay, so I got up to here where we had 2,880 ways to have an A and no 5, and we'd found this was the way to have an A and a 5. So the last scenario I've got to look at is this one here, a 5 and no A, and then we're just going to add those three numbers together. So if we want to have a 5 and no A, I mean the reasoning should be getting pretty obvious by now. We've got two letters here, and then we've got the four numbers that we're going to choose here. So the first bit is going to be 4P2, this is for 5 and no A, and then we're going to have three non-5 numbers to choose from 6 numbers, so that's going to be 6P3, and then there are 4 places that I can put the 5. So all of that looks like this. We're going to have 4 times 3 for the first bit, times 4 for this, times 6, times 5, times 4 for the other ones. Right? You can do it like that, or you can use your 6P3 formula, which is 6 factorial over 3 factorial. Anyway, all up you will get 5,760. So if you're going to do the scenario method, it's just really important that you label what you're doing, right? So something like what I've done here with 5 and no A and no 5. The examiner's report said that a lot of people got confused about whether the A scenario included a 5 or not. You really need to break it down into the 3 cases. So when you add those up, not surprisingly, you'll get the number that we got earlier, which was, I think, 16, not 16,800. What was it? 12, whatever it was. I don't know. 12, was it 11? Okay, it's whatever that number is from the last video. Really, the reason I'm doing this video is to do the very last bit of this question, which is this one here, which sounds really hard, but actually it's pretty easy if you just don't overthink it too much. Find the probability that the code is DE followed by a number between 4,500 and 5,000, and it's 3 marks. I think it's much, much less work for 3 marks than this question here. The first thing to think about is that we already found back up here that there were 16,800 codes that could be formed. So the way that I'm going to do this, I think by far the easiest way, is just to say how many of those codes are going to have the pattern that we want, right? So again, we've got the 2 letters. So the 2 letters here, and then we've got the 4 codes. So if the 2 letters have got to be D and E, we don't have to think about the 2 letters anymore. And then the codes have to be between 4,500 and 5,000. Right, so how can I have between 4,500 and 5,000? Well, the letters we've got to work with are not all of them. We've only got 1, 2, 3, 4, 5, 6, 7. Nothing can be repeated. So if I've got a 4 here, I could have a 5 here, or I could have a 4 here and a 6 here, or I could have a 4 here and a 7 here. And then I've just got 5 numbers left to work with in here. So how many ways are there going to be to have this happen? Well, I've got 3 ways, 1 for each of these rows, and then I'm choosing 2 numbers out of a group of 5 numbers. So it's 3 lots of 5P2. Or the really slow way to do it is just to work out that here we've got 5 times 4 ways. Here we've got 5 times 4 ways. And here we've got 5 times 4 ways. So this is going to work out to be 60 altogether, right? So that's the fastest way to see it, is that for each of these cases, I've got these 2 and then choosing 2 from 5. Okay, so what does that mean? Well, it means that there are 60 codes out there that have DE and then somewhere between 4,500 and 5,000. So the probability that we have DE and then a number from 4,500 to 5,000 is simply equal to 60 divided by this. Now, I didn't actually look at what that simplifies to be beforehand, so let's do it slowly now. So 6 divided by 1680, shove it into your calculator, or we're going to do it slowly, 3 divided by 840 is what I'm getting there. I think that's right. And that won't simplify because I've got a prime number in my top line. And you could write that as a decimal to 3 significant figures. So there you go, a pretty big perms and comms question, but lots of great stuff to think about in there. Remember, the difference is that combinations are when I don't care about the order, and the definition of that is 5 factorial over 3 factorial, 2 factorial. But when I do care about the order, I'm going to use permutations, which is just going to be 5 factorial over 3 factorial. Thanks for watching. Send in any questions that you're having trouble with.